Hi everyone, this video is on exercise 9i, the challenge question. And in this video, I'm going to do question 1. And in the next video, I'll do question 2. So we have to prove that every cubic curve has exactly one point of inflection. The first thing is to remember that the general form of a cubic function f of x is ax cubed plus bx squared plus cx plus d. So this is the general form of a cubic function. Now, in order to find the point of inflection, we first need to find the second derivative. So let's differentiate. First, f dash x is equal to 3ax squared plus 2bx plus c, and the second derivative is equal to 6ax plus 2b. So this is our second derivative. And in order to find the point of inflection, we need to solve the equation f double dash x is equal to 0. So we solve f double dash x is equal to 0, which means 6ax plus 2b is equal to 0. That means we divide both sides by 3 to get divide both sides by 2. So we get 3ax plus b is equal to 0. And then we need to rearrange this. So 3ax is equal to minus b, and x is equal to minus b over 3a. So at this point, we can't say that minus b over 3 is going to be the x coordinates of the point of inflection, because we need to check the sign of the curve just before and after x in order to prove that's the point of inflection. So what we do is that we need to check the behavior of the second derivative just before and after the value of x that we found. So we can write minus b over 3a, and just after that is by adding a small value. Let's call that a small value epsilon. And then for the time that I said we find a value just before that, we can take away a small value called epsilon. Okay, now it's just a matter of substituting these into f double dash x to find the values. And for the first one, we are going to have 3a times minus b over 3a plus epsilon plus b. Sorry, here I made a mistake in substitution, because the equation of f double dash x is 6ax plus 2b. So I mistakenly substituted into 3ax plus b. This is basically solving the equation and simplifying that. That's not the actual f double dash x. So should be careful. The actual equation is 6a times x, and for x we substitute minus b over 3a plus epsilon and then plus 2b is equal to, and this is equal to 6a epsilon, and this value is greater than 0, because remember that epsilon here, I should have said that, is a small positive value. So it's a very small positive value. When we introduce epsilon, we should mention its sign. It's very important. It's a small positive value, and so that 6a epsilon is a positive value. And then for the negative epsilon, it's going to be again 6a, but this time minus b over 3a minus epsilon plus 2b is equal to, so this time we are going to get minus 6a epsilon, which is a negative value. And this is exactly what we wanted. So we check whether x is equal to minus b over 3a is the x coordinate of the point of inflection. And that's indeed true, because when we checked the behavior of f double dash x just before and after x, we got values with opposite signs. So this means that thus every cubic function has only one point of inflection. So that's very important here, because we only basically got 1 point of inflection here, and we also showed that that's the point of inflection. All right, so that's it for this video, and thank you for watching.